right, in this question, it says a neutron decays by emitting a beta minus particle. Complete the equation below for this decay. All right. So we've got a neutron here, and the yields, symbol is right here. So a neutron yields what? Just sort of when we do this. Well, this is the symbol here for an antineutrino. That's actually the next question. An antineutrino is neither a proton nor a nucleon. So it's like its numbers are 0, 0. It doesn't have anything there. The beta minus particle is an electron. So we can kind of think about its proton number as being -1, but it doesn't really have any mass. Okay. And so here we've got the neutron had to be, become something. It emitted this beta minus particle and an antineutrino. All right, so mathematically we'd say, well, -1 plus 0 is -1. So something here has to be a +1 right there, right? So in other words, you got 1 plus -1 plus 0 to equal 0 over here. So this has to be 1, and this has to be 1 also, because again, the top sort of numbers have to balance also. So both nucleon number and proton number is conserved. And we look at this, we say, well, what's something that's 1, 1? That's either you put a P for proton or an H for hydrogen. So that's just a hydrogen atom. So a neutron, became hydrogen, or it might be better to actually think about that as, a neutron becomes a proton. But what is something with 1 proton? Hydrogen. So those things are sort of interchangeable there. I already mentioned that this nu bar, okay, so this is the Greek letter nu, it represents a neutrino. The bar on top means it's an antiparticle, so it's an antineutrino. State the name of the class or group of particles that includes beta minus and antineutrinos. Those are our leptons. State the quark structure of the neutron. Well, a neutron consists of down, down, up. You might want to sort of write those out, but D for down. So there's 2 down quarks and 1 up quark. There's those 3 quarks that make up a neutron. The change to the quark structure when the neutron decays. So we go back up here, we say, well, this neutron was what? It was down, down, up. This proton here is up, up, down. And so a down quark, flips to an up. Down becomes up. It can be more complete. So, proton, well, we shouldn't assume that the reader understands that when the neutron decays, it becomes a proton. So the product, of this decay will have, down, up, up, which is a proton. You can sort of state it like that. So product consists of 1 down, but now there's 2 ups, right? So down, up, up, which is the quark structure of a proton, right? So a neutron becomes a proton. That's what we see here. Proton is a hydrogen atom. Pretty straightforward, 6 marks right there. This has been another work example with Dr. Schleich, and we'll see you next time.